Welcome to Study Loop.
The objective is to analyze the rates of reaction and deactivation of a catalytic reaction or in a basket reactor at a constant gas composition despite catalyst deactivation, based on the results of two runs with different initial concentrations of reactant. First, we need to understand the experimental setup. The reaction A-R is taking place in a basket reactor, which means that there is a mixed flow of gas and solids. The gas composition is kept constant throughout the experiment, even though the catalyst is deactivating. To maintain the gas concentration, the flow rate of reactant had to be lowered to 5% of the initial value. Next, we need to look at the data from the two runs. In run 1, the initial concentration of a cow is 1 mol/liter, and the time from the start of the run is given in hours. The conversion of it to RXA is also given, along with the amount of catalyst used gm/liter. The data is given for 4 time points, 0, 1, 2 and 3 hours. However, for time points 2 and 3 the data is missing and is denoted by E and ETWO, respectively. In run 2 the initial concentration of air is 2 mol/liter and the conversion and catalyst amount data is given for the same time points as in run 1. However, the data for time points 2 and 3 is given in exponential form 2 and 2 ETWO, respectively. From this data, we can make a few observations. First, we can see that the conversion of A to R increases with time in both runs. This suggests that the reaction is proceeding, at least initially. However, we also see that the amount of catalyst used decreases with time, indicating that the catalyst is deactivating. To get a better understanding of the rates of reaction and deactivation, we need to analyze the data more closely. One way to do this is to plot the conversion of A versus time for each run, as well as the amount of catalyst used versus time. We can then use these plots to estimate the reaction rate and catalyst deactivation rate. Another approach is to use mathematical models to fit the data and extract the relevant parameters. For example, we could use a rate equation to describe the reaction kinetics and a deactivation model to describe the catalyst behavior. We could then use these models to simulate the experimental data and estimate the parameters that best fit the data. Overall, the data suggests that the reaction is proceeding but that the catalyst is deactivating. To fully understand the kinetics of this reaction, we would need to analyze the data more closely and use appropriate models to extract the relevant parameters.